Hello friends, welcome to my YouTube channel of Debneel's Mathematics Desk. So as you can see, today's video is for my friends of class 9. So then before starting my video, huge thanks to all of you for supporting my channel so well. Huge thanks actually. So then keep supporting my channel. If you found my videos interesting and informative as well, leave a like and share and subscribe my channel. It means a lot to me and motivates me to make better videos for you. Alright, without wasting much more time, let's get into our content of the video, which you can see on your screen is rational and irrational numbers part 1, class 9. So this chapter is all about means understanding. Okay, you have to understand means what are the means core concepts, and the sums they are actually quite normal. Okay, so we will see. So basically let us see what we will learn today. First of all, a rational number. Let me first tell you this. Rational number is given in this form. Rational number, I am telling. It is given in this form. P by Q, where I don't know why my red pen is not working well. Use the black. Alright. Where your P is what? P can be anything. Okay. P can be a whole number, natural number, or integer. Alright. Okay. And Q can be anything. Just like this. So I am putting commas because commas means these are same. Okay. Except 0. That means the rational number shouldn't be in the form of p by 0. This is not right. This value is considered as undefined. Okay. Means the value is means it is impossible. Let's consider this. So the denominator of this rational number q shouldn't be 0 and p can be anything, as you can see. That is a rational number. Alright. And irrational numbers are what? Actually, they're endless. Okay, that's all, nothing else. Irrational numbers. So suppose I have a number 3 by 20. Okay, so what is that? That means 3 by 20 if you do goes for 6, 2, point comes again 6, 2, 0, again 6. So this keeps going on. Okay, this keeps going on. It's endless. So guys, just give me 1 minute. There are some noises in the background. So just 1 second. I guess so for the delay, actually some background noises were disturbing me, so that's why. So this is another thing. Let us not focus on this first. Okay, irrational number. See here, what I told, P can be a whole number, natural number, integer. Q can be anything except 0. But suppose these type of numbers, like this. Okay, or suppose 1 by 2 root 2. These type of numbers, see, we actually can't express them directly in a ratio. Okay, this root 2, it has an endless value. All right, so numbers that can be expressed in a direct ratio, all right, that those are called irrational numbers. See, what is root 2's value here? Root 2's value is something 1.414141 and keeps going on. So we can't express this in a direct ratio, because in ratios we can't have this type of roots. Okay, and we can have roots, but if you convert this into the decimal form, then it's a endless, means this is not a proper ratio. Similarly, this is what, this is actually 6 root 2 by 1. Again, root 2's value is undefined, means infinite. So numbers which can't be expressed in a proper ratio, those are called irrational numbers, as the term suggests. Okay, now something else is there. How can we check if a number is convertible into a terminating decimal? So terminating decimal is what? Means suppose I am telling you this 3 by 20. Okay, so basically after you divide this, this becomes a 6.6666 dot dot and keeps going on. So terminating decimals are those means which have a means fixed number of digits after the decimal point. But see this, these are endless. So this is a non-terminating decimal. Okay. So when you see that, when you divide, means after solving a ratio, if you divide the numerator by the denominator and you see in the decimal value there are more than means infinite numbers in the decimal place, then that is a non-terminating decimal. And when you see a definite number of means units, suppose I can consider as 2 by, suppose 15 by 2, this is 7.5. So see, we have only one digit after the decimal point. This is a terminating decimal. Okay, and if you want to see if a if a number is a means terminating decimal or not, means if a ratio is convertible into a terminating decimal or not, then check this. The denominator should be representable in the form of 2 to the power m into 5 to the power n. All right. So this is one thing that you have to consider while checking if a number is in terminating decimal form or not. Okay. So you understood this? So basically, if you want to check if a number is in terminating decimal, means convertible into terminating decimal, you can directly divide and see if there are fixed values after the decimal point, but you can use this as well. Okay. So let's solve some sums. So we now learned what is the rational number. It is p by q, where p can be anything, but q can be anything as well except the number 0. If it is 0, then the rational number is undefined, not possible. Irrational numbers are those which can't be expressed in a fixed ratio, which means value is an endless value actually. Those are irrational numbers. And terminating decimals are those which have a fixed number of digits after the decimal point. Okay. And to express, to see if a number is a terminating decimal or not, the condition is the rational number. The denominator of the rational number should be representable in the form of 2 to the power m into 5 to the power n. Okay, so means suppose I'm telling you like this, suppose one question, 2 by 125. So you have to consider the denominator. So what if we factorize 125? This is by 5, it is 25, by 5 it is 5, by 5 it is 1. That means 5 cube. And remember one thing, this formula, a to the power 0 equal to 1. So we can write it into 2 to the power 0, right? It will not change it, the value of 125, but this is representable in the form of 2 to the power m into 5 to the power n. That means this 2 by 125, it is a terminable, not terminating decimal, means it has fixed values after the decimal point. Okay, so that is how you have to check only if a number is a terminating decimal or not, and solve some basic concepts on rational numbers in today's video. Okay, so let's begin. So I hope you can now understand what are these. All right, so let's begin. So I am telling you the questions, they are not that hard. I think my black pen is also bad, I think. Let me just see, guys. Okay, let's start. Question 1. So we have to tell here if the statements are true or false. Every whole number is a natural number. What is it? Is it true or false? T slash F. So see, every whole number is a natural number. So, what do whole numbers begin with? Whole numbers are, so whole number 0. Let me write in red. Let's try in blue, okay? We are underestimating blue. Blue is a good color. The whole number 0. 0 is a whole number. That's no issues with that. But is 0 a natural number? No natural number start from 1. 0 is not a natural number. So this statement is wrong. Every whole number is not a natural number because the whole number 0 is not a natural number. So this is false. Okay? This was the first question. Let's write another one. Every whole number is a rational number. Okay. Now see this. T or F. So the whole number 0, suppose. 0, it is actually 0 by 1, it is 0. And 0 by 1 is a rational number because 0 by 1, then P and Q and both are integers. 0 and 1 both are integers, and Q is not equal to 0, so it's satisfying. Similarly, all other numbers like 1 equal to 1 by 1, 2 equal to 2 by 1, 3 equal to 3 by 1. So they all are means fractional numbers, right? So then this statement is absolutely correct, because if you divide every whole number by 1, then that it remains as the whole number. And if suppose I divide any number, suppose 0 by 1, I told you, 2 by 1, 2 and 1 both are integers, okay? Not integers, 2 and 1, they both lie as whole numbers or integers. 2 is a whole number, and then 1, it is not, means Q's value is not equal to 0. So that is a rational number. So all numbers like these, it means divided, so they are rational whole numbers as well. 0, if you these natural numbers and whole numbers, they have only one difference. Whole numbers start with 0 and natural numbers start with 1. So the 0 is the main protagonist. Okay. So 0 by 1, I already told you it is absolutely right. It is a rational number, and 0 by 1 equal to 0. That is a whole number. For 1 by 1, 2 by 1, if you check, the statements are absolutely correct. And this statement is true. Okay. So this was another question. So you have to understand properly. See from the question what they are telling. And means you can do trial and error method like this. 0 equal to 0 by 1. P and Q, P comma Q not equal to 0. So this is a rational number and this equal to 0, that is a whole number. Then try for 1, 2, 3, 4, a few numbers, for the first few numbers. And check that if the conditions are satisfying or not. Okay. So then if you find the conditions are satisfying, then the statement will be correct. Very easy. Let's see the next one. Every integer is a rational number. T or F. If we divide, integers are what? Numbers less than 0, numbers more than 0, and the 0 as well. If we divide any integer value by 1, suppose I divide minus 5 by 1, then minus 5 by 1, it is a rational number. P by Q, they both line, means P lies in the category of integers slash whole numbers slash natural numbers, and minus 5 by 1, that means 1 is not equal to 0, or Q's value is not equal to 0. That is a rational number, and minus 5 by 1 equal to minus 5, that is an integer. So if we divide any integer by 1, then that becomes a rational number. So that means every integer is a rational number. Also applicable for 0, which is also integer. 0 by 1, that is a rational number. P and Q means P is an integer and Q's value is not equal to 0. So that is a rational number, and 0 by 1 equal to 0. 0 is an integer. So statement is absolutely correct. This is true. Okay. Now next one. Every rational number is a whole number. What? Is this true? Okay. So this is an inverted statement actually. If you carefully observe, this is the opposite of question 2. Is this correct? Is this correct? Suppose I consider the rational number 3 by 4. Okay. Now, this is the rational number P and Q. Okay. And Q's value is not equal to 0. P's value can be anything, right? So now, 3 by 4 is what? It is 0.75 if I convert to decimal. Is this anyhow a whole number? Whole numbers are 0, 1, 2, 3, 4, 5. Not these fractional numbers. Okay. So they are not whole numbers. Similarly, 4 by 5, 0.80. 5 by 6, 6 by 7. You can't get them as whole numbers. Okay. So this statement is not correct. Okay, every rational number is not a whole number. If the numbers, yes, these numbers are whole numbers. Okay. 8 by 2, suppose 4. That is a whole number. But suppose these numbers 3 by 4, 4 by 5, 5 by 6, what wrong have they done? They are also rational numbers, but they are not whole numbers. If you divide them, it's a decimal number. Okay. So this statement is false. Wow. In true and false, we got equality. 2 false and 2 true. Very good. So let's proceed to the next type of sums. Okay. In part 1, if you understand the basics properly, if you know how can you form a rational number, then you can. And what is terminating decimal? How you can check if a number is a terminating decimal or rational number? Then you can solve this part 1. It's very easy. Let's proceed. Question 5. They are telling arrange minus 5 by 7, 7 by 12, minus 2 by 3, 11 by 8, I suppose. Yeah, in ascending order. All right. Find the difference between the largest and smallest numbers. Smallest as a decimal number and only one number after decimal place. Big question. Okay, this is a very big question, I'm telling you. But it is easy. So let us solve. So what we have to do is first, see, if we can make the denominators same, then the numerators will tell us which is bigger and which is larger. So what can I do is take out the lowest common multiple of 7, 12, 3 and 8. Okay. So what is it? Just I am thinking what can be the number. Minus 5 by 7. Let me just think, guys, what can be the lowest common multiple of 7, 12, 3 and 8. Okay. So then what can be the lowest common multiple of 7, 12, 3 and 8? Let me just check. 7 into 12 to 3 into 8. This is what 7, 12 are 84. 84 into 3, 252 into 8. Okay. So this becomes 7 into 12, 84 into 3, 252 into 8. 6, 1, 4, 14. Okay. Okay, so you can do that. Actually, it's complicated to find the LCM. So what you can do is multiply all, means all of these numbers to get the lowest common multiple. No need to find the LCM always. You can multiply all these numbers as well. So then this becomes what? Or minus 5 by 7 equal to minus 1416 by 7 minus 5 by 7. So the lowest common multiple LCM will be 1416. 1416. What is this? 1416 divided by 7 into minus 5. Okay. Right. And similarly 7 by 12, what will it be? 7 by 12 equal to 1416 divided by 12 into 7 divided by 12. We are just means converting the denominators into 1416. Okay. So minus 2 by 3 equal to 1416 by 3 into minus 2 by This is 1416, correction. 1416. Okay. Similarly, 11 by 8, this is equal to what? 1416 by 8 into 11 by 1416. Okay, so these are the numbers if we now have the same denominator. Now 1416, so let's see, or minus 5 by 7. 1416 by 7, if you calculate, let me just check, something is wrong here. So it's 84, 215 to 8, 6 and 1 and 4, sorry, this will be 2016. Sorry guys for the mistake. Okay, yeah, so this is actually not that, I put it by mistake. This 2016 by 7, this is 2016. We have to drop this 1416. These are wrong. Okay, they are given a big sum actually. No worries, we will do it. No one can stop us. Okay. So now minus 5 by 7. 2016 by 7. This is 7 2s are 14. 6 and 1. 8. 5 and 6. 8. Okay. Yep. Into minus 5. Okay, I'm writing directly. Okay. So 288 into minus 5. It is minus 1440 divided by 2016. Got it. 7 by 12, what is it? 2016 by 12, 181, 1 then 8, 1, 6, 8, 168, 1, 8, 1, 6, 9, yes. So 168 into 7, it is equal to 1176, I think. Let me just check. 168 into 7. Yeah, 1176 by 2016. You know, big calculation. Okay, so we have to be careful while doing. Again, minus 2 by 3 is what? 2016 by 3. This is equal to divide this by 3, 6, 217, 672, I think. 672. Yeah. So 672 into minus 2. This is equal to minus 1344, I think. 672 into minus 2. Yes, minus 1344 by 2016. And 11 by 8. This is what? 2016 by 8. This is 2415. I'm just calculating. Okay, you can do this division. I'm doing it myself. So 252. So 252 into 11. This is equal to 2772. Yeah. By 2016. Now see, what have we done is we converted them into the common denominator by multiplying all these denominators to get 2016. So then converting into the common denominator, we got these respective values. Now, as denominators are same, we have to now check which numerator is greater than whom. So in ascending order, okay. So it will start with the smallest. Which is the smallest numerator? Obviously minus, and minus 1440 is smallest. Okay. Minus 1440 by 2016. I'm adding in bracket the actual value so that it can be done much more quickly. It is less than the next small value in the minus, again minus 1344. by 2016, which is actually minus 2 by 3. Again, this is less than. Now in a positive side, we have this one numerator as small. So 1176 by 2016, and that's the value of 7 by 12. Okay, and the largest one at the end, and that is obviously this 2772 by 2016 minus 2 by 11, sorry, not minus 2 by 3, 11 by 8. So as you can see, then the correct order is minus 5 by 7, then minus 2 by 3, 7 by 12, then 11 by 8. This is the correct sequence of ascending order for these four numbers. Okay, so we found out the means, multiplying all them, we got 2016. Use this 2016 to make the denominators same and got the respective numerators. Now we see in the numerators which is the smallest and the largest. According to them, we arrange them in ascending and descending order. Okay. Now what they have told us is, find the difference between the largest and the smallest as a decimal number. Okay. So the largest is this one, 11 by 8. And the smallest is this one. So therefore, now I am writing this one. Okay. So I am writing directly now largest, or 2772 by 2016 minus the smallest, which is minus 1440 by 2016. Minus 1440 by 2016. This minus will become plus, equal to 2772 plus 1440 by 2016. If you know the addition of fractions, you will be able to solve this. And that's what, this is nothing but 2772 plus 1440. It is 4212. Okay. By 2016. Okay, let's just simplify this. This becomes 2106. This becomes 1008. Okay, we can divide them by 3. It becomes 702. This also can be divided by 3. Divide this by 3, 3, then 103, 186. Okay, then again, this can again be divided by 3. If you divide this by 3, it becomes 2103,124. Divide this by 3, it is 118. Again, this is again factored as well. Dividing this by 2, 117. Dividing this by 2, it is 59. So actually it turns out to be 117 by 59. Okay. So what we can do, let's divide. We have been told to express this as a decimal number, only one number after the decimal place. So let's divide 117 divided by 59. Okay. So this turns out to be okay, I have given it wrongly, I think. 59 by 117 actually. Sorry. So this is 159. So that becomes 58. Put a point. 0 comes out 9 times. 59 nines are, you will tell, I am telling. Okay. So that is 531. 49. And then another 0 point is there, so 0 will come. So then let's do a little calculation. If you multiply this by 8, it becomes, okay, 5, 9 to 8 to 72, and 7 in hand, 8 into 5, 40, plus 7, 47, yeah, 18. So let it be. So we have got 1.98. Okay. So we have been told to only express in one decimal place. So you can keep this as 1.9. Okay. Equal to 1.9. actually you could have, I didn't need to do this second division. So after you divide, you get this as 1.9 your actual value. Okay, so then this is how you have to do it. First of all, after to arrange them, you have to make the denominator same as I have done here, means by multiplying them. Then after you get the respective numerators of the numbers, check which numerator is smallest and arrange them in that way, and then put the values aside for the actual values. That is the correct ascending order. Then the largest minus the smallest. If you do that, you will get this. Do a little bit simplification. You get 117 by 59, and then do this division accordingly to get your desired result. So very well, no harm in the question. It was actually a big one. That's why it took so much space. But who cares? We did it correctly, right? We did it correctly. Actually, I think the largest sum in my channel, the largest sum by the means of space. Let's do a few more questions. Is 0 a rational number? Can it be written in the form of P or in P by Q? We know this. Let's still do. P by Q. Where P and Q are integers. Comma Q not equal to 0, I think it's given. Yeah. Okay. 0. It's an important number. Okay. It increases every value. If you put a 0 after any number, suppose 2, then another 0, it keeps on increasing. Huge help in mathematics. Okay. So 45 write 0 as 0 by 1. So or 0 by 2 or 0 by 3, whatever. Anything. 0 by n, comma n should be not equal to 0. So what have I written it like? P by Q. Yes. P by Q, P by Q, P by Q. P and Q here all are integers. Okay. N belongs to I. I means integers. P and Q are integers like 0 and 1 or 0 or 2 or 0 or 3 or 0 by n, suppose any number, suppose 120, 240, anything. Those are integers. And what I have told here, Q is not equal to 0. So now see these numbers 0 by 1. 0 divided by any number, it is 0. Okay. So that is actually possible. So Q is not equal to 0, the Q and P and Q both in all cases are integers. And these values are equal to 0. So then, therefore, yes is the answer. Short answer, but remember this process, okay? For these things, Q can be anything not equal to 0, and for the question, it should belong to integers, and the numerator should be 0. Okay, then only you will get the value as 0. Alright, that's how you have to solve this question. This comes as a question in the beginning of the question paper in many exams. It's a conceptual question. So let's see some more things. Now they are telling us, is 7 by 16 convertible into a terminating decimal? See, for terminating decimal, what I told, denominator should be representable in what form? 2 to the power m into 5 to the power n. Okay. So let's say the denominator 16. 16 is what? 16 by 2, 8. 16, 2 by 4, 2, 1. So or 16 equal to 2 to the power 4 I can write. And what I have told, any number to the power 0 equal to 1. So can't I write this as into 5 to the power 0? See, 2 to the power 4 into 5 to the power 0 or 1 is 16 only, no harm. But this is representable, or 16 is representable as 2 to the power m into 5 to the power n. See, 2 to the power m into 5 to the power n, it is representable, okay. Therefore, as the number is presentable in this form, therefore it is convertible. That's what you have to check. If the denominator is in this form, then it is convertible. If not, it is not convertible, non-terminating decimal. Okay, let's solve like that a few more questions. This is very easy. Okay, this principle let me write one side. I rub it mistakenly. Okay, let's do. Let's check out a few more means numbers. So now I'm just directly writing terminating decimal or not. That is the question actually for the next few sums. Okay. So what are the numbers now? 23 by 125. Let's check. Or 125. Let's factorize. Dividing this by 5, it becomes 25. Again by 5, 5 by 5, 1. Therefore 125 is what? Equal to 5 cubed. I told any number to the power 0 equal to 1. So can be written as into 2 to the power 0. 5 to the power 3 into 2 to the power 0 or 1 is 125 only. No violation. And this is representable as 2 to the power m into 5 to the power n. Right? Very easy. See? 2 to the power m into 5 to the power n. That means therefore it is convertible. That's the basic logic of this sums. Check the denominator. If it is representable in this form, it is convertible. If not, so no. Very easy. We have only 2 sums left today. I told you part 1, it's about the basic concepts. If you understand them properly, then you are the boss of part 1. But part 1 will help us to solve various operations of rational and irrational numbers in part 2, which we will see in the next video, not till now. Now I have 32 by 45. Now let's take out 45. Or 45. First, see, we can't divide the number at first. We know for factorization, the smallest number has to be divided, okay, at the beginning. So it is divisible by 3. See, 45 by 3 is 15. 15 is also divided by 3, 5. 5 by 5, 1. So what is 45 then? 45 equal to 3 to the power 2 into 5 or 5 to the power 1. If you also write it 2 to the power 0, then this is not in this form. 2 to the power m into 5 to the power m. Okay. 3 is the means protagonist here. So, as it is not representable as 2 to the power m into 5 to the power n, therefore non-convertible. So this was the answer no's case. So we checked the denominator and found out that it was 3 square into 5 to the power 1. Putting 2 to the power 0 in the other side doesn't mean that it is 5 means 5 to the power m into 2 to the power n. Another 3 to the power something is there. That can't be there. If it is there, then the denominator, it is not in this form of 2 to the power m into 5 to the power n. And the answer then will be this number. It is non-terminating decimal or non-convertible into terminating decimal form. Okay. So remember these things. The last sum for today. Basic concept. So we will not take much time. Last question. So they are giving us 123 by 250. So let's say the denominator 250. 250 by 2, 125, again by 5, 25, by 5, 5, and by 5, 1. Right, so this is what, or 250 is what, equal to 5, 2 to the power 1 into 5 to the power 3. See, 2 to the power 1, 2 one time, and 5 to the power 3. So this is directly in 2 to the power m to 5 to the power n. Oh, not n, m, sorry, it is n. Directly 2 to the power n to 5 to the power n, directly it is given, therefore convertible. So easy, right? Just check the denominator after factorization. What is the means exponential form? If it is 2 to the power m into 5 to the power n form, it is convertible into terminating decimal. If not, then not to be the case, the answer is non-convertible. So that is what we have here for rational irrational numbers, class 9 part 1. We learned how to frame a rational number where p can be anything but q shouldn't be equal to 0 and anything else. Okay. And we also learned what is irrational number. Any number which is means in the can't be expressed in a rational form, like 1 by 6 to the power root 2, and root 2's value is infinite. That is an irrational number. Okay. And then we learned about terminating decimal. Terminating decimal is what? A decimal number which has definite number of means units after the decimal point is a terminating decimal. A number which has means infinite number of terms after the decimal point, it is a non-terminating decimal. To check if a number, rational number, is in terminating decimal form or not, check if the denominator after factorization, its exponential form, is in the form of 2 to the power m into 5 to the power n. If it is in the form, it is terminating decimal, and if it is not in the form of 2 to the power m into 5 to the power n, it is a non-terminating decimal. So I gave a brief summary of what we have learned today. So we are hoping that part 2 is going to be more interesting because we will have new operations on this chapter. This chapter has many key core concepts, so we will have to understand them properly. So we will meet in part 2 for class 9 rational and irrational numbers. Till then, if you found my video on this chapters part 1 for class 9 informative and helpful, and all the core concepts and formulas and sums were solved and clear to you, leave a like and share and subscribe my channel. It means a lot to me and motivates me to make better videos for my little friends. Till my next video on part 2 for this chapter, with a lot of love from my side to all my little friends. Take care and goodbye. Thank you.